Well, hello. So for this video, we're going to be talking about the local maximum and local minimum point of a given graph. So we're going to look at two different examples. So whenever we're looking at a local max and local min, we are talking about the highest and the lowest point in your graph, excluding its end behavior. So kind of if we were going to get rid of the ends of these graphs, right? Because we know this graph is going to go on and on forever. It's never going to truly reach its highest max or min point because it goes on forever. But if we ignore the ends and we just take a look kind of like the middle of the graph, right? The big chunk in the middle, what's really going on, where we have all the turns and everything like that. In that sense, what would the highest point be? What would the lowest point be? Right? So we're going to take a look at the local max first. And typically it's a two-part question when it comes to dealing with local max and min. Where does it occur? And that is the y value for it. So what is the local max or what is the local min? And that is the y value for that highest or lowest point. And then where does it occur at? That is going to be our x value for that point. Where on the x-axis does it occur? And then what is that high or low point for it? So our local max, to just start off here, is going to be this point right over here, right? Excluding the ends of our graph, that is the highest point that we have here, the top of the mountain, if you would say. All right. So that local maximum has a height of 3. So the local max is 3, and it occurs at, well, if we go down to its x value, it occurs at a -6. So our graph reached a maximum local height at 3 when it is at a -6 on our x-axis. And its min looks to be a point right down over here. So we're going to guesstimate a little bit. With that point here, it looks like that minimum point. So if we look at our y value, it does look like that's about a -9 there. And that's going to occur at the x value. So if we go up, our x value looks to be about a 2.5 is what I would say. So its lowest point is at a -9. And that occurs when we are at a positive 2.5 on the x-axis. So let's take a look at our next example here. So when we're looking at a local max, remember that the maximum point has to be higher than every other point around it, excluding the ends of the graph. So if we chop off the ends of our graph here, the highest points on our graph is this line right over here. The graph doesn't go any higher than that. But this does not fit our criteria. These points are all exactly the same height, which means none of them are higher than the other one, right? So you kind of think of it as a contest, like who's the number one? Who is the highest point? Since none of these are higher than the other one, since they're all tied, we don't have a true winner. So there is no local max for this particular example. Now there is a minimum point though. So if we look here at our graph, so it does look like we have a minimum point sitting right over here at a -5. So that's our low point, right? Our low point occurs, our low point is -5, and it occurs at, if we go up to our x value, that looks about a 4.5, we'll say.